Segment 6, Profiling Segments. We're looking at a 6-segment solution obtained for the vacation motifs dataset, and we want to now use visualization methods to profile the market segment and to identify the defining characteristics of the market segment. So the first thing we want to note is that the order of the variables in which they are contained in the dataset is arbitrary. So we could order them in whatever way we like, and it makes sense to think of a reasonable ordering, which would help us then to identify the important characteristics of segments. And one idea is we could try to group similar vacation motifs together. Grouping similar things together, we already know how to do this. This is what clustering does. So now what we want to do is we don't want to cluster respondents, but we want to cluster variables. And we will use hierarchical clustering for this. So we calculate the distance matrix, but not between respondents, but between variables. So we're transposing the matrix containing the respondents in the rows and the variables in the columns. By transposition, we get the variables in the rows and the respondents in the columns, and then we calculate the distance matrix for that. This means we get now a 20 by 20 distance matrix using Euclidean distance by default, and then we use hierarchical clustering on it using word clustering. So this gives us now a clustering solution, and we want to look at how good were we. So we'll visualize the dendrogram. And we want to use not the default plot function for objects returned by H-class, but we want to use the plot function for dendrograms, which has more features. For this, we coerce the object returned by H-class to a dendrogram using sDendrogram. And then this object here has the dendrogram class, and the plot method for dendrograms now gives us nice plots which allow us to rotate the dendrogram. Horse equals true means we rotate it to the default dendrogram plot we've already seen by 90 degrees. And we want to have a triangle type. How we are the lines which connect, how should they be shaped? And we add a label for the x-axis because we rotated it by 90 degrees, and we'll have names for each of the singleton groups. These names are the variable names, and they are quite long, so we'll need space. And to make space, we are using here par. Par is a function which allows us to adjust the settings of the plotting window. And mar is we want to change the margin. And what we want to do is we keep the same margin for the bottom, because here this is a vector of length 4, and this includes the information on how much margin do we have at the bottom, how much do we have to the left, how much to the top, how much to the right. So we keep the same margin as the default for the bottom. We reduce the margin on the left and on the top, and we increase the margin for the right hand side. And par changes the setting for our plotting window, and it returns by default what were the settings before we change them, so we can set them back afterwards. So par opar will restore the default settings before we change them. So we're changing that settings, and then we make the plot. So we see, because we added here more space, we have place to put in the variable names, and the triangular shape can also be seen by these lines. What we can see is, otherwise it's a normal dendrogram, and we see, for example, culture, offers, and lifestyle was put together as being close, and we're using now this ordering for plotting our profiles. How are we doing this? For plotting the profiles, I need to still set back the default settings. So we want to have the normal margins back. We're using the function bar chart for that k-mean solution. So bar chart has a specific method for k-mean solution. We put in shade equals true. So we want to have marker variables highlighted. We'll see in a moment what marker variables are, and this switch allows us to select the variables we want to have included in the profile plot and in which order. And we're using the order identified by hierarchical clustering, and we reverse it. This gives us this profile plot. Get a bar plot for each of the clusters, and one of these bar plots is called a panel. And so within one panel, we have here the strip is the information what's contained in that panel. Here that's cluster 1. Here we have the number of respondents in that cluster. It's 235. That corresponds to 24% of the respondents. So here you can see what's plotted and how big is the cluster. And the bar plot indicates the average level of agreement with that vacation motive within that cluster. And the red dot is the population average. So the red dot with the line, they're everywhere in all panels in the same position because they reflect the population average. And the bars are the cluster specific averages. So we can here see in cluster 1 that it has the tendency to agree less than expected in the average population on all of the vacation motifs. But we also see that some are pink and some are grayed out. And the pink ones, those in color, are the marker variables, and those grayed out have not been identified as marker variables. What are the conditions that a variable is identified as a marker variable? It's either a marker variable if the difference between the population average and the cluster average is more than 25 percentage points, or if the relative difference between the population average and the cluster average is more than 50%. So we have an absolute and a relative criterion. If either of the two is fulfilled, then a variable qualifies as a marker variable and is put in color.